Hello students, and welcome back to our physics revision class. So today we are going to discuss vectors, chapter 2 of grade 11 physics. So as you know, physical quantities are they are quantitative description of a physical phenomena. We have different kind of physical quantities, but these physical quantities can be classified into two. Some of them are called scalars and the other are called vectors. Okay, scalars are physical quantities which are expressed using only magnitude, but vectors are physical quantities which are expressed using both in magnitude and direction. Okay, so normally operating with vectors is a bit complicated. That's why we need to learn about them. But when we come to scalars, operating with scalars is very simple. It's like operating with numbers. Okay. But when we come to vectors, adding and addition and multiplications in vectors are a bit complicated, because in vectors, not only the magnitude, but also the direction is equally important, okay? So vectors are physical quantities which are described by magnitude and direction, like force, acceleration, velocity. These are examples of vectors. So we represent vectors either graphically using a line segment with an arrow on it. The length of the line segment represents the magnitude of the vector and the arrow shows the direction. Or we can simply represent a vector using symbols, okay, like F for force. So operating with vectors, now adding, we can add two vectors either graphically or analytically. In a graphical addition of vectors, we use scale diagrams and we connect vectors head to tail, okay? For example, if this is vector A and if this is vector B, okay? Then by drawing a scale diagram, okay, this is A, then we connect the tail of B to the head of A, this is B, then this is, the resultant is always drawn from the tail of the first vector to the head of the last vector, so this is A plus B. So this is what we call graphical method, okay? But analytically, we use different mathematical theorems and postulates to add vectors, okay? So if two vectors are in the same direction, we simply add their magnitude so that the resultant vector has the same direction as the two vectors. But if the two vectors are in opposite direction, we subtract their magnitude and the resultant vector will have a direction the same as the direction of the larger vector. And if the two vectors are perpendicular to each other, for example, in this way, so this is A and B, so the resultant can be determined by using Pythagoras theorem and trigonometry, okay? From Pythagoras theorem, you know that C square is equal to A square plus B square for right angle triangle. So the resultant vector A plus B or R square is equal to vector A square plus B square, okay? And if this is theta, then we can determine the value of theta using one of the three trigonometric functions, like tan theta is equal to opposite over adjacent, B over A. So with the help of Pythagoras theorem and trigonometry, we can find the resultant of two vectors, okay? So another thing about vectors is resolution of vectors. Resolution is to break down a given vector into its components. For example, as you can see, we have a vector A, which makes an angle theta with the positive x-axis. So this vector A can be decomposed into two components. The first component is AX, the x component of vector A, which is given by A cos theta, and the vertical component is AY, which is given by A sin theta, okay? A sin theta. Then we have different kinds of vectors. There is a vector which we call zero vector. Zero vector is a vector which has a magnitude of 0 and an arbitrary direction. There are also a unit vector. A unit vector is a vector that has a magnitude of unit 1. And we have three important unit vectors in our discussion of physics, the I, J, and K unit vectors. These are unit vectors that represent the positive x, y, and z direction respectively. So that any vector in a three-dimensional coordinate system can be expressed using these three unit vectors as AXI plus AYJ plus AZK, okay? So if a vector is expressed in such a way, then the magnitude of the vector can be expressed using AX squared plus AY squared plus AZ squared. So under radicals, this is how we determine the magnitude of a vector, okay? So when we come to vector multiplication, we have three kinds of multiplication in vector. The first one is multiplying a vector with a scalar. So multiplying a scalar with a vector result is with another vector. We can give an example for this, like force is equal to mass times acceleration from Newton's second law of motion. So as you can see, mass is a scalar, but acceleration is a vector. So a scalar multiplied by a vector gives us another vector, okay? So the direction of A and B is determined by the value of K. If K is a positive number, then A and B will be parallel. They will have the same direction. But if K is a negative number, then they are in opposite direction, okay? So another kind of multiplication in vector is what we call the dot product. Dot product has another name which we call scalar product. So as the name indicates, by multiplying two vectors we get a scalar physical quantity. So for two non-zero vectors A and B, the dot product between A and B, A dotted B is given as the magnitude of A multiplied by the magnitude of B multiplied by cos theta, where theta is the angle between A and B. Where theta is the angle between A and B. So if A and B are expressed in terms of the unit vectors I, J, and K, then the dot product of A and B, A dotted B, will be given by AX BX plus AY BY plus AZ BZ, okay? So dot product has different application in physics. One of the application of dot product is it will help us to find an angle between two vectors. You can see that from this cos theta can be expressed as A dotted B divided by the magnitude of A multiplied by the magnitude of B, okay? So from this we can calculate the angle between two vectors. And from dot product we can also use it to calculate work done. As you know, work done in physics is defined as force dotted with displacement. Both force and displacement are vector physical quantities, but work done is a scalar physical quantity. Okay? So these are some of the applications of dot product. The third kind of multiplication of vectors is called what we call the vector product or cross product of two vectors. So if we are given two non-zero vectors A and B, then the cross product of A and B denoted by A cross B is equal to the magnitude of A multiplied by the magnitude of B multiplied by sine theta multiplied by n, okay? Where n is a unit vector which is perpendicular to both A and B. So as a result, A cross B is a vector which has a direction the same as the unit vector n, okay? A cross B will be perpendicular to both A and B, okay? So mathematically, if two vectors are given in terms of the orthogonal unit vectors I, J, and K, for example, if A is given as AXI plus AYJ plus AZK, and if B is given as BXI plus BYJ plus BZK, then the cross product of A cross with B is given by AYBZ minus AZBY in the I. So this multiplied by this minus this multiplied by this times I. Then this multiplied by this minus this multiplied by this times minus J. And finally this multiplied this AX BY minus AY BX in the K direction. As you can see, a number in the I plus a number in the J plus a number in the K gives us another vector. So the cross product of two vectors is another vector which is perpendicular to both vectors A and B. Okay? So the cross product also have some different applications in physics. The first application, it can be used to determine the moment of a force, that's a torque. For example, if a force F is acting on an object which is fixed at this position and making an angle theta here, if this is a distance r, then the torque is given by r perpendicular times F. So torque is equal to r perpendicular means this is a perpendicular direction of r, we can call it x, and from trigonometry we know that sine theta is equal to x over r. From this, x is equal to r sine theta. So in terms of r perpendicular, we can use r sine theta times F. This can be expressed in terms of cross product as r cross with F, okay? This is one way to determine the torque by a force, torque by a force. Okay, so another application, this can also be used to determine the magnetic force of a charged particle when it's moving in an external magnetic field. If you remember, whenever a charged particle is moving in an external magnetic field, it experiences a force, and the force is dependent on four factors. The first one is the magnitude of the charge. The second one is the speed at which the particle is moving. The third one is the magnetic field strength. And the fourth one is the angle that the velocity of the particle is making with the field, okay? So finally, we come up with the expression F is equal to Q times V times B times sine theta. So which obviously the force is perpendicular to both the velocity and the magnetic field. Then we can express the force F as Q into V cross with B. Okay? So another application for cross product is it can help us to determine the magnetic force on a charged particle when it's moving in an external magnetic field. Okay? In an external magnetic field. So basically, this is one of the most important topics of grade 11 physics. So I hope you find this very useful. So I hope that you will do some practical exercise on these topics. So this is all for today. Until next time, stay safe.